Okay. If there's no question about your quiz, actually for your quiz, for your reference, I did add some points to your base points. So yeah, that's for your quiz, but maybe it will be different for your midterm. Okay. And your midterm next week. Is that okay? The, yeah, chapter 10, 11, and 12. So, do you have other course schedule for midterm? When? Huh? 20. Yeah, this calculus will be 23rd. Okay? Huh? Yeah, good. Yeah. Okay, so actually today I will start a new chapter. It's chapter 12. It's about the factors. I hope you watch the video, okay? Because I won't repeating the same things. So it's called factors and geometry of space. So at the very beginning, the introductions, I mentioned if you have a three-dimensional Cartesian, if I asking if this is z, this is x, this is y. For your reference, the graph or the pictures or the Cartesian axis, it can be like this, or if you prefer this one, you can also draw like this. Depends on you, but maybe I will draw like this. Okay, the y-axis will be like this. If you are more familiar with this picture, but it will be the same. Okay, if I'm asking z equal 5, can you point out or can you make out the z equal 5 in this Cartesian, in this three-dimensional Cartesian? Where is z equal 5? You have 1, 2, 3, 4. This is 5, right? But that's the point. That's the dot, right? Like for example, if you have two-dimensional, this is x and y, right? Where is y equal 3? Here, right? Only dot or line? Line, right? So you just need to draw a line. At least this line is y equal 3. So back to the three-dimensional. Z equal 5. Will it be dot, line, or what? Yeah, it's a plane. It's a surface. Okay. So to draw, my suggestion in this chapter, because it will be very complicated in terms of visual, I need you to maybe watch some video about the three-dimensional factors to give some good visualization. Okay, because most of the time this chapter will deal with the drawing. So z equal 5 is a surface, it's a plane. Let me draw. So for example, So imagine this plane. This plane is intersect with this 5 here. So imagine that you have a rectangle, but the rectangle itself, it is the length, okay? It's having infinite length in x and y. So it's infinite surface, okay? The same thing if you are using the x equal maybe 6. So we need to find the point. This is 6. Then it will be like this. And the principle is the same. The axis within the surface in z and y line, it will be infinite. The length will be infinite. Okay. And for the introduction, please go watch the YouTube video. I already mentioned the model in the model. So I will go forward. For now, this is just a simple intro in the YouTube video. I will go into the formula for the vectors, and I think most of you are still remember, but maybe I'm just reviewing. So first, let me go for the new page. Okay. So first is dot product. Do you still remember? Dot product. Remember? Good. So if you have A, if A is A1, A2, and B. Remember, if I'm drawing like this, it means it's a vector. Okay. So if I make a dot product between A and B, it will be A dot B. It will be A1, B1 plus okay, I hope you remember. And the general terms will be okay. I don't need to show you how this works, okay, because you already given many times. The second is the cross product. I think cross product shows or in application it's more useful in some physics phenomenon, right? For example, when you are using your wrench, you have torque, right? You have some angle when you use your wrench, and it's using the cross product, right? The radius cross your force. No, don't remember? No, remember? Okay, forget it. Torque, torsion. You remember torsion? It's a cross product. Cross from the radius of the wrench and the force. Okay, and you have the angle, right? Okay. So cross product, if you have, let me write A1. So if I have write A cross B, it will be A2 B3 minus A3 B2, and then A1 B3 minus A3 B1, right? And then what else? A1 B2 minus A2 B1. Okay. Confused? don't remember? This is B1. You can use the uh, so to apply the cross product, okay. So if you want to know the cross product for the x-axis, the I, okay. So I, J, K, you need to remember that is when you are using, we call I, J, K is the basis factors, which means this is 0, 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay. Yeah, please watch the video. I put all there. So for I, for X, look at this, okay? Then you find the determinant, okay? Remember determinant? No? Okay, please relearn. but the term will be determinant, which means this A2 B3 minus this, okay? And if you want to multiply by I, you can do it. So you can have the x-axis a value for the factors. And similarly, okay, similarly, if you want to see the y, so j, so see here, j and a2, b2 here. So a1, b3 minus a3, b1. Also the k, the z-axis, it will be a1, b2 minus a2, b1. Oh yeah, this will be minus. So I just minus in the front. And here also minus here, right? Or maybe minus plus. So it should be positive, negative, positive. Okay. And actually, in matrix, you can also use the other row and column, and it will result in the same result. But I prefer this one for default. Or maybe I will write here the cross product. Also, you can write the absolute value or the value, the magnitude. It's the same as A, B, and sine theta. And then here, A cross B, we can say is orthogonal to factor A and factor B. Do you know what this means? Orthogonal to A and B? Using your right hand, okay? Cross product is your thumbs, okay? This is your first terms. Like for example, A is my index finger, A, and my middle finger is B, A cross B, right? Yeah. So A cross B. Can you imagine a screw? You are putting a screw by, if you want to make it go inside, you need to make it to the right? Clockwise. And when you want to remove, you want to the left, right? So it's the same. So you want to make it remove, right? To the left, right? This A, B to the left. Imagine. Okay? Got it? It's very simple. Yeah. Right. Okay. That's cross product. It will be useful for your all any matrix or any factor based calculations. it will be much more needed in, I think, in mechanical engineering. Please remember that. If you cannot figure out the right hand rules, you will be having difficult time learning torque, learning all the stress, strain, all the formula. Usually it's having a factor. Okay. Okay, what else? Okay. Dot product and cross product, just summary. Very fast, right? Yeah, very fast. So after this, the next section will be, so we learn, in the video you will learn the space, how to write or draw the space, and then some factor introductions, and then dot product, cross product. And the next section will be factors in line equations, and plane. And then I think at the very end, you will learn the quadric surface. That will be very, very difficult. Quadric surface means you learn conic sections, right? You know how that will looks like in the 2 dimension. How in the 3 dimension? You can combine cone or maybe ellipse and parabola. And then ellipse and hyperbola. You will learn at the very end.
Can we just skip that one? Due to coronavirus, can we just skip that one?
No. That part is, if you are learning and how to trace the shape, the graph, how to shape the graph, either you will love it or you will hate it.
I think I know my answer.
Okay, so for lines, okay, I will just write this as lines. The general equation will be, we are writing the line equation with R0 plus T and V. What is R? What is V? It is all factors, okay, except the T. The T is the same T as in our parametric equation. This is the parameter. Okay. So let me draw the illustration. So for example, this is our, let's say, L. This is Z, X, Y. So the red one will be our R0 or R0, the initial factor. And the point, I will write the point as P. Maybe X, Y, and the blue one will be the our R, and it is the P. And the green one is V. So sometimes we call the V is the directions, okay, the directions, okay, so that the initial factor, when you are plus the V with some parameter, it will go to the R factors. So I will, this is just illustration, okay. The V, it can be any direction it wants. Okay. So if I write my R is X, YZ, and V is ABC. So I can write the vector XYZ is equal to, the initial is x0, y0, z, right? So x0 plus t a, y0 plus t b, z0 plus t c. So this is what we call the line equation through factors. The t is a parameter, okay? T is parameter. So when you are multiply the parameter with the directions, with the v, and then plus the initial point, that will be your total, how to say, total distance to move from the initial point to the R point at the end. Okay. So we can say also this is the parametric equation for a line through the point. Okay, remember, if I writing the bracket like this, meaning it's point, but if I change the bracket into this one, it will be the factor. Okay. Okay. So parametric equation for a line through this initial point and parallel to the direction factor, that's the phi direction factor. ABC, X will be, I'm just writing the same conclusion. Okay. So phi is a how to say that? It's just a factor, but when you are multiply that factor and it become parallel, then it will be your directions factor. So for example, find a factor equation. Factor equation is the R. I'll write here. This is factor equation. And this is parametric equations. Okay. So find the factor equation, parametric equation for line pass through point 5, 1, 3, and parallel to factor I plus 4j minus 2k. So it will be not too difficult, right? So you have the point. This is your initial point, right? And this is your directional factor. So 1, 4. This is your V. This is your R0. So R will be Let me write in the ijk. So 5i plus j plus t so r will be it will be 5. Hmm? Yeah.
But we don't have to write the K and I.
Yeah, sure. Yeah. You can have several ways to write the factor. Choose which one you want to write. Like for example, you can write this. This is also fine. Okay, finish? Finish? Yeah, factor equation. Actually, you want to complete the answer. The R is a factor equation, and you can write the parametric each x, y, and z. So you can write parametric equation will be 5 plus t you can write separately parametric equation and or just the factor equation. Okay, good. Okay, so another way to describe another form to describe the L, the line. You can, I will copy here. So remember you have the parametric equation here. I can write the t, okay. I will write x and also t is y and z, right? So I can write this as this is what we call a symmetric equation of the line. Okay. I think it's quite easy to understand because this symmetric equation is just the form from the parametric equation, and you need to solve the t. A, B, C is component of factor that parallel. So this is symmetric equations. Let me give you some example. find parametric equation and symmetric equation of line pass through just this. Can you try to solve based on what you already done?
Let's go.
So find parametric and symmetric equations of a line that pass through point A 2 4 minus 3 and point B 3 minus 1 1. Try.
So the x0 is x from A, and A is x from B. Yeah, Mas.
So first you need to make the which one is your initial point, right?
A.
Yeah. Actually, you can use A or B. As long as you are consistent throughout the process,
A.
you will get the answer eventually. So if you choose A, then you choose the factors, how to find the factors. It's not a factor, it's a point.
It's a point. B minus A.
Yes.
Yes.
That when you get the factor AB, right? So let's write the factor AB is B minus A, 3 minus 2, 1, or I will write down all.
Can you change your G?
So you get the factor AB. So taking this as your phi, okay, or direction, because if you're taking this vector as your direction, of course it will be parallel to any of both of these points, right? So we can use this point or this vector AB as your v, as your direction vector, and then we can choose maybe A is our initial point. So initial point 2 4 minus 3. So parametric equation will be x 2 plus t, y 4 minus 5t, and z is minus 3 what plus 40. Okay. Actually, if you already find how, or you find the how to solve it, which one is which one, right? And then you will find it is actually easy. Truly, I say it truly. In line it's still easy, but maybe in plane a little bit complex. But not as difficult as the last part. Huh? Yeah, BA, right? Factor BA. Yeah. And you are starting with the initial point B. You can also do it. This is the parametric, and then you can also I will write the symmetric first. Okay. Symmetric equation. It will be x minus 2 over 1 this is symmetric equations. If there is an additional questions, for example, at what point this line intersect xy plane. Can you understand what the question means? At what point this line intersect xy plane? No. Yeah, z equals 0. So if you are confused about the questions, maybe you can draw to make some good illustrations. So what the question asking is, this is z, x, y, right? So it's asking what point this line intersect xy plane. This is xy plane here, right? Like that, right? So it will always crossing the z, right? It will always intersect z. If you're asking xz plane, it will be here, right? So xy plane will be z equals 0 because it's not included in the plane. So that's why it will always intersect that axis. Xz plane is y equals 0, right? And yz plane x equals 0. Actually, this section is if you are choosing to not memorize all the things, it is pretty fun for like a puzzle. If you or try to think this is a puzzle, like you are drawing some movement, and imagine if you trace your shape, your graph, right? So back to the question: at what point this line intersect xy plane? So we have the symmetric equation, right? So let's equal z equals 0. So x minus 2. Let me write all the symmetric. So z equals 0, right? So it's 3 over 4. So first, x minus 2 is 3 over 4. X is what? 11 over 4. And y minus 4 is, and y is plus 16, right? So 1 over 4, yes. Yeah. So L intersect xy plane at okay. 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 Questions? No? The next one is we call the line segment. Actually, it's the same thing as our vector equation, but let me write for you. So I will write, we know R is, this is the vector equation. If line also pass through the tip of, let's say, R1. Okay. Yeah. We can take the direction vector R1 minus R0. Yeah, segment. So R will be R0 plus T R1 minus R0. So the line segment from R1 to from R0 to R1. So line segment means you have the vector equations, right? Imagine the vector equation being a line, and you want to make a segment in between that line. You can use these expressions. So the idea is you are using the direction vector in between the segment you want to observe. For example, the segment is R1. So your direction vector will be r1 minus r0. Hmm? Hmm?
Just the whole node, or is it stop?
Oh wait, delay.
Oh, delay.
Oh yeah. Okay. Yeah. So the line segment. You can imagine the line segment is you have the vector equation as a line, and you want to observe each segment. R1 is you can imagine R1 can be any point in that line. So actually, it's the basic is the same as the vector equation, but you can write the vector equation as a segment using the R1. So in another way, you are rewriting your direction vector because you are changing the direction vector into R1 minus R0. R0 to R1. So actually the line segment from R0 to R1, we just change all the V. R1 minus R0. Actually this is the same thing, but just to change the V. And that is for the line. So dot cross line equations and then plane. Very fast, right? With the assumption you have already know the introduction of the vectors and you have learned previously from physics, right? And maybe from the basic math or maybe your high school math. Some of the problem is the high school math, right? It's except the space. I think the space or three dimension only few touch the high school part. Yes. Which one? The video McLaren, yeah. Yeah, it will be in the midterm. Yeah, it's chapter 11, still chapter 11. Yes. The McLaren and Taylor series is the chapter 11, end of the chapter 11. I'm still choosing the question for your midterm. Maybe by the end of this week, I will post in the Moodle which part you need to make emphasize. I'm not sure because your quiz already good, right?
Good is questionable. Good is
Maybe one. Maybe. So we have 6 chapters, right? So 3. So midterm 1 will be 3, and then the final will be 3 under the 3. So two tests. But maybe the quiz, because the quiz based on 2 chapters, so the quiz will be 3 times. The exam will be 2. But the quiz depends. Okay, maybe only 2, maybe 3. I think it's already controllable. Taiwan is already safe. Yeah, Taiwan already safe. I think. After summer it will be safe. Yeah, there is no official announcement about it. The official announcement is saying if your class is more than 60. So if under 60, you can still have a class. And I think the situation is still controllable. There is no significant rising, right? Okay, that's the line segment.
But now Taiwan is in urge of being taken over by China
Yeah.
because of the regulation problem.
Yeah, I don't know why they had that problem. You know, the Taiwan team they won a competition organized by WHO.
What competition?
How to I forget it's about the health system, and the team I think it's from the Cheng Kung University.
Yeah.
They got the first prize. Then they're Taiwanese, so it's quite funny.
The one who win it is actually not in the WHO. Yeah, ironically.
So let me draw some illustration for the planes. Okay, imagine you have in 3 dimension, you have a plane. Okay, you have the initial point P0, and it will go through the P, okay, P0 and P. So from P0 move to P, and I hope you still remember. If you have plane like this, and you have a line, I call this line N. Do you know what that means? What does that mean? The N means?
Perpendicular.
Yeah. The name, the terms. You have parallel, and then what kind of vector is that? Yeah, orthogonal, but the terms. Oh, it starts with N. Yeah. Yeah, this is the normal vector. Normal vector. Yeah, maybe in some books in big N, but I think in math I usually N, small n. So I'll write the N is orthogonal.
Why that is R0 and R?
Wait.
Okay.
So R and R0 is actually our vector, okay? And I will move from the R0 to R. So actually it's long, right? And at some point, I will move the R0 to R and making the plane. Okay. So the plane, okay, so you have this line L, okay, and you have the plane. So the line L is actually in the plane. Okay. So imagine this is the R, this is the R0. The vector, if you are drawing a vector, usually you draw like a small line, right? But actually, the vectors goes through infinitely if there's no other vector in between, right? So it will be go through here. So at some point, I will say from here until here, I will say the R0 goes to R. This is L. And this L, this line, is a part of a plane. So you can make out a plane from that L. So the plane is actually how to say that? A lot of L, right?
So like the plane is actually
Yes. So you have all line, and when you put all together, it becomes plane. That's why you can make out a plane from vectors. Okay. So I will write the R minus R0 represent the vector P0P. Okay, because we want from this point P0 go to P, right? Yeah. So orthogonal means the n, the normal vector, when you dot with the R minus R0 is 0. Okay. So you can have or you can have the vector equation of plane. So there will be at least three components to draw a plane or to observe a plane. At least three components. You have the normal vector. Okay. So I will write maybe here at least three components. Orthogonal, the dot product. Dot product. Okay, cos 90, right? Remember? No? Okay, cos 90. Because it's this is 90 degree. So at least three components. First is the normal vector. It's denoted by, let's just write ABC. So usually in vector, if you see any ABC in the total vectors, ABC means it's the directions. Usually, okay. And then you have the R. This is the final point or final the vector equation, the whole equation R, and then the initial vector. So at least you need to obtain these three components. So from P initial point, if you have initial point with normal vector, so the vector equation will be A, or it's not vector equation, it's the plane. We call this is the scalar of the plane. Why is 0? It's actually from the orthogonal equations. Yeah, it's from the dot product, with the orthogonal, the normal vector. Here, the R minus R0. And just expanding the A, B, C, and x0, y0.
The normal vector is from the P0.
The normal vector, you can say the normal vector from P0, from P, anywhere, as long as it's the same direction.
Oh, you mean like that?
Yeah. Okay? It's just the equations of the plane. Right?
Okay, sir. Never mind, sir.
It's something you call scalaric of the plane, or yeah, you can just say it's equation of the plane is also fine. Okay, questions? No? Finish this part? Okay? Finish? Okay, let me move to another notes. You can write also the linear equation.
Linear equation.
And then, yeah, it's the constant. You can also find the distance. So distance between 2 points from the plane. Okay. I will just write the formula. Yeah, the big D is distance. Small d is just constant. So this equation of plane or linear equations is ax plus by plus cz plus d equals 0. You can find the exact equations after you are plug in the point, and you will find some equation with x, y, z that you can say the equation of the plane. Constant, constant, constant.
Oh, like that.
Okay. Let's go for some example questions so that you can familiar with all the line and plane equations. Hmm.
Itu apa ya?
Big D, small d,
The big D.
distance, distance
From what to what?
between plane,
Between plate,
plane, plane.
plane. You mean the linear equation is like the so you mean the linear equation is like
For the plane, for the plane.
so which A is that and which X is that?
A, B, C is the directions. X, Y, Z is the point. So when you get all the relation between the point and the factor point and all,
Oh, this is from the previous one.
yeah. And then you can plug in the point and you can get the exact number.
This is from N.
Mm.
And then the
It will be more intuitive in the examples, but I will go for the line example first and then plane. Okay, so find a factor equation and parametric equation for the line A through point and parallel to factor okay. First, you have these questions. Find factor equation, parametric equations. I think it's still easy, right? Factor equation means finding the R. R is equal to R0 plus T V. V is the direction factor. So R0, because the question is quite simple, it's just say through point something and then the parallel to factor. You have the point. Let's make the point as your initial point and then the factor as your direction point. So R0 will be, I will make it a factor. So I'm making a factor R0, meaning the point and the origin 0, 0, 0, right? So you know that it will be a factor. And then factor V is the 1, 3, okay? So R yeah, this is the factor equation. This is the parametric equation. Simple, right?
Wow, so simple, sir.
Huh? Simple, right?
Wow, so simple, sir.
I have around 4 or 5 questions. Yeah, this is the line, and then I will give you the plane. Well, I will give you the line first, maybe after 2 questions. Okay? Hmm? Okay, okay. Sure, sure. Too long, too long. One.
How to get PhD with no knowledge. Boleh dicoba, boleh dicoba, boleh dicoba. Terus mereka mau beli gitu. Setelah kopi. Hubungan. Panjang. Banyak obstacle. Dari mulai kawannya.
Okay? Finish? Okay. The second questions. This is A, this is B. The same question, find factor equation and parametric equations. Line through point.
Ini apa nih? Aku pengen PhD nggak? Aku sampai biar kayak Stephen gitu, biar kayak Stephen. Aku pengen PhD.
So the same questions, finding the factor equation and finding the parametric equations. But can you solve this one? It's not really direct question, so you need to find out.
Line to point, blah blah blah. Zero from parallel to line. So what are we finding?
First, do you understand the questions? Understand? Yeah, you find the V from the clue is parallel to this line, right? So
Just take the fee, right?
yes, correct.
239.
Yeah. That's the direction means. Okay. So the direction will be this one, the red color here. That will be the directions. 2, -3, and +9. So I will write the R0 will be 14J, and phi will be 2I. Okay. And then the factor will be R. So R will be 2T I plus, because it's 0, right? 14 minus 3T. Okay, so this is the factor equation, parametric equations. Okay. Okay, next example, the plane. Find okay. So try the equation of plane. Find equation of plane. So the plane through point 632 and perpendicular to factor minus 2, 1, 1, 5.
Through point perpendicular to factor.
So at least you get the first point, like, right, the initial point. Okay, you can make it as a factor, and then it should be perpendicular to factor minus 2, 1, 5. You can go directly to the normal factor.
Oh yeah,
Right, right.
the normal factor.
Yeah.
So the equation yang ax plus by normal factor.
So let me write this as the perpendicular factor. It will be the normal factor. Normal factor to the plane. 632. This is initial point. Okay, so from the normal factor, we get A is minus 2, B is 1. Oh yeah, wait.
So the equation is ax plus by plus the
Yeah,
oh that one.
but you need to use the equation before, and it will form that equation.
Oh, the ax.
Yeah.
Oh. Oh, so the d comes from there. Okay. Okay.
Why so long? Okay, and then we go directly to our formula, the this one, or I will write all, or just the result. And I solve these equations, and you get the equation of plane, or the linear equation of the plane. So equation of plane. Solve this with delay. I will just write all. While still delaying, I'll write the other. Yes. Yes. Yeah. Let me stop the mirror. Okay. Okay. At last. Okay. So this is the equation of plane. Okay. So you just plug in the formula from the previous slides. Plug in the A, B, C, and then use the x0, y0, z0, and just plug in all the information. Solve the equation, you get the equation of plane.
Friendly just softly says way in the background. How to find a vector that is perpendicular to other vectors?
Through the dot product.
Oh. Then what is the dot product?
Make it zero, right?
Zero.
Right, right.
Okay.
Okay, I think this. Huh? No, the dot. Perpendicular, you need to use the dot product to find the perpendicular, because dot product, you have the cos 90. Yeah, you can use that also and use the sign, but I prefer to use the cosine through the dot product, because the cosine, it will be perpendicular when it's 90, right? And it will be zero. It's much easier to use. Yes. Depends on question. You can find in some case.
So the D is
The constant is yeah. But you can just stop here and you can just write the equation of plane is this. Okay. I have one more questions. You have line 1 and line 2. Okay. The question is L1 and L2 parallel? Is L1 and L2 intersect each other? And is L1 and L2 are skew lines?
Let's do S.
Skew. Yeah, S. So line 1 using the T as a parameter and L2 using S as a parameter to differentiate between those two. Okay.
So when C equal X, and when T equal X.
Yeah. Yeah, you can say that. So skew lines means they do not intersect, they do not parallel.
So they're apart.
Yeah.
Just like
Yeah.
just like X. Sir, what is S?
It's the parameter, same as T, but I need to differentiate because it is two line. I need to show it's two line.
Oh, like that's
So how you are going to observe or evaluate either both the lines parallel or maybe they intersect each other, or maybe not in the same plane. They are not parallel, not intersect each other.
use one S equal T.
Yeah. Almost. Yeah, what did you say before?
You use S equal T. Use the same term.
Yeah, you can say that.
Use S and T equal 0.
No. Any suggestions how to solve? Yeah, but that's a bit too far. The early how we do know this lines is parallel. Yeah, but I think it's too far. Just equaling the line 1 and line 2 and then solve T and S like linear equation. Use substitution, right? Like this. So line 1 should be line 2, assuming it's parallel, right? Assume parallel. So 1 plus T is 2S. And then negative 2 plus 3T is 3 plus S. And we have also 4 minus T equal negative 3. So you have linear equations, right? So linear equations, you have these three equations, right? So you can check 1 and 2, check 2 and 3, maybe 1 and 3, but just check 2 is fine. And then check when you get the T and S, check in other equation. Is it the same or not? If it's still the same, then it is parallel. So if you try to solve 1 and 2, eventually you can try, okay, by yourself. Eventually you will get T is equal and S is equal, and try this T and S plug in into this equation. Is it equal or not? No, right? Yeah, because 8 over 5, it will be 32 something. 11 is too far, right? It's 40 something in the left and 30 something on the right. So L1 and L2 is not parallel. It's skew lines. How to say that? Skew.
Not parallel.
Yeah.
Not parallel. Not parallel.
Okay. Actually, until the plane, we finish until the plane. We just need one more sections. We call it cylinders or quadratic surface.
Nice.
Okay.
What's nice about that?
Nice.
Nice.
Midterm 12. Okay. I think we can finish today and see you Thursday. I will go for the cylinders and quadratic surface.
So,
And maybe a review for this last part because there is some notes, but I will keep it for next week. Okay.